Hi, welcome to Google Cloud's digital conference. Let's talk AI. I'm Marcel Babai, Senior Sales Engineer at Looker.
I'm Alex Hanna, a technical curriculum developer at Google Cloud.
Today we're going to talk about BigQuery machine learning and Looker and how they fit together. We have Googlers on standby ready to answer your questions live, so please click on the icon to your left and ask away. To get us started off, Alex is going to give us an introduction of BigQuery and BigQuery machine learning.
Thanks, Marcel. So BigQuery, many of you probably used it. BigQuery is Google Cloud Platform's enterprise data warehouse for analytics. It's got petabyte scale storage for queries, and it uses standard SQL, so your data analysts can use it with knowledge of that standard language. It's encrypted, durable, and highly available, and it's no-op, it's serverless. You don't have to spin up any kind of VM, it all runs in the cloud. You also get real-time analytics on your streaming data. So we're in the business of Google being an AI-first company. What does that mean? So we built our machine learning foundations. In the 1990s, we were focused on building our data warehouses, accruing data, and focusing on building data-driven solutions. In the 2000s, we've moved to BI foundations. Data warehousing formed the foundation of business intelligence and analytics. Now we have BigQuery, Google's data warehouse, and that's been focused on scaling up to the petabyte scale and thinking about data from a fundamentally different approach. So being able to deliver analytics and intelligence in mere seconds, not minutes or hours. And the next step of that is an ML foundation, being able to leverage ML tools and foundations for organizations using machine intelligence. And we're going to do that with many different tools, but here focusing on BigQuery ML. The problem is that with BigQuery, with ML and ML modeling, it often takes days or even months developing an ML model. So you can either take one of two paths. You can start off in Excel or Sheets, and you can get a little bit of data. You can develop a linear regression model or a logistic regression model within Sheets. You can build your model, and it has low accuracy because you don't have too much data. You can go back and get more data and create new features, improve performance, but it's going to be kind of slow. You can only do it so much because the application can only handle so much data, and then you stop because it's hard, and you get a model with only so much accuracy. On the other hand, you could go and use a tool like TensorFlow or scikit-learn. You export a small amount of data from BigQuery, your data warehouse, and then you create frames of data for use with your TensorFlow build model. You go back and create more and more data and improve in performance. And this can only usually be done by an expert data scientist, someone who may have a master's degree or a PhD and has to have a very large body of knowledge to go about and do this. Okay. So this is really where BigQuery ML comes into play. So what if I told you that we can create a machine learning model in less than 5 minutes? You go, Alex, that's ridiculous. Well, let me tell you, it is ridiculous. I'm going to show you how. So this is our BigQuery screen. We've got here below this, a standard, below these lines here, I'm going to come back to these all important lines. We have standard SQL, so we're selecting from a select statement from an e-commerce table, our visitor ID, our bounces, that's the number of bounces the user had, and the time they've spent on the site. These are the two primary features on which we're going to build our machine learning model. And we're trying to predict whether that visitor to the site is going to purchase something upon a return visit. Now I go up here and I'm creating in 2 lines, create or replace a model, and I'm building a classification model in 2 lines of SQL. That's right, 2 lines of SQL. So I write create or replace model, the model name, and with options, the model type, logistic regression, it's a classification task, and then the labels I want it to predict. Will the user buy on return visit? That's it. Standard SQL, 2 lines, and we have a machine learning model. That is wild. So I'm going to run this, and in the background, this is going to run in under 5 minutes. So this is where BigQuery ML comes into play. The key challenges affecting ML is that it's expensive for companies to hire data scientists. Data scientists have to have that depth and breadth of experience and that advanced degree or training. The second part of it is that it's complex and time consuming to move data in and out of your data warehouse. You have to set up these long ETLs, you have to keep on feeding data, you have to maybe have a data engineer on staff to handle this. And so BigQuery ML handles that by doing machine learning within SQL and within BigQuery. Okay. So in our example that we're running right now, we got our data from Google Analytics 360. We all had that data within BigQuery. We used machine learning within BigQuery ML to develop a model and do predictions. We reported it out through our BI platforms, Data Studio, Tableau, and Looker, which Marcel is going to tell us a bunch more in a bit. And then we retrain that model quickly. And at the end, we get a high quality model from which we can connect with email marketing and ad campaigns. So BigQML really hits that sweet spot in the middle. On one end, we have our developers who may be not familiar with machine learning, have some knowledge of machine learning, but are not data scientists. And for that purpose, we have tools like AutoML and CloudML APIs, our Vision API, our Translate API, those different APIs that live in the cloud. You don't have to know anything about machine learning engineering. You have to know what machine learning is. You have to have sets of labels from which you can predict and build a model. But AutoML and the CloudML APIs do the rest. On the other extreme, you have your data scientists. And data scientists build state-of-the-art custom models in TensorFlow. They deploy them on Cloud ML Engine. And this typically requires a deep understanding of machine learning and programming, some kind of advanced training. And in the middle, we have this sweet spot with BigQuery ML. Your SQL analysts, folks that you have on staff, your data analysts, have a good understanding of machine learning, but can't build these custom models or don't have that kind of training, but they do have a basic understanding of machine learning. So this really empowers those folks to go out and build those models. So you bring ML to your data using BigQuery ML. It uses familiar SQL for machine learning. You can train models over all your data in BigQuery. So really leveraging that data warehouse and that data warehousing infrastructure and that super fast query infrastructure that BigQuery already has built in. And you don't have to worry about things like hypertuning or feature transformations. BigQuery ML does that all within the tool. And so we've seen some really cool customer use cases here. So Hearst has predicted customer churn. Geotab has predicted weather-based harsh driving prediction in cities, pulling in public weather data and also all this data on where folks are driving. News UK has done customer subscription prediction. Smart Parking has predicted traffic prediction for smart cities. And Reblaze has done this Cloud AMER, automated IP threat protection. I want to zoom in a little bit on 20th Century Fox, who has a really cool use case in which they've been doing audience conversion for media planning. So identifying folks, media and consumers who may be interested in their new movies coming out, and identifying those folks who may be interested in targeting them with a particular ad campaign. So these folks have all been in the BigQuery ML Alpha and have really been able to leverage this really awesome and really cool ways. So the syntax, as I said, is ridiculously easy. It's like 2 lines. So to train a model, create or replace model, the model name, the options, the model type. So linear regression for a regression task, logistic regression for a classification task, the label, the sort of thing you're trying to predict. In this case, the number of trips. This is like a taxi prediction model. And then to predict, select the predicted label and then a date from ml.predict model and then your data set name and then your features. That's it. Literally 2 lines of SQL in addition to a normal SQL statement which you're selecting which features you want to use. That's really cool. Behind the scenes, there's of course a lot of things happening. So for you to do this in 2 lines of SQL, you're leveraging BigQuery's processing power to build this model. BigQuery has these really quick processing speeds to go through all these petabytes and terabytes of data that you have in your data warehouse. So it's able to query that at lightning speed. It's auto-tuning your learning rate and auto-splitting data into training and test. It's standardizing numerical features. You don't have to worry about that kind of standardization and doing one-hot encoding of strings. For the advanced user, if you have data scientists on your team or folks who are more familiar with machine learning, you can do things like L1 and L2 regularization. You can specify different strategies for training and test split, like random, sequential, or anything else you want to think up yourself that's appropriate for your data. And you can manually set the learning rate. So you can get in under the hood if you'd like. There's other supported features like standard SQL and user-defined functions within the ML queries. Currently, BigQuery ML supports linear regression for forecasting and then binary and multinomial logistic regression for classification. With this, you get things like model evaluation with the standard metrics like the ROC curve, precision, and recall. You can inspect your model weights for dissecting what's happening within the model, and you can also do feature distribution analysis through standard functions. So I want to go back to our demo real quick, and let's see. And it has run. So we had here, and I was true to my word, 4 minutes and 24 seconds, our model has been trained. We can go back, and if I go here and I click the name of my model, I can see all kinds of details on my model. I can see that it was a logistic regression. I can see what loss was specified. If I go ahead and I click on my model stats, I can see every iteration here. I can see my training data loss and my evaluation data loss. I can see the different learning rates. We see the learning rate has been adjusted automatically, and how long it took to process each iteration of the model. So we had a pretty good loss just with these 2 features, training data loss at 0.07 and our evaluation data loss at 0.069. So really good, doesn't seem to be overfitting in any kind of way. So with those 2 lines of SQL, able to really build this powerful model, which we can now use for predicting things out of our sample. So another great thing is that we can toss our results from BigQuery ML, our evaluation, and our predictions to our favorite BI platforms. So we have hookups into Tableau right here. Data Studio as another. We see examples of the ROC, recall, and precision curves. And I'm going to pass it to Marcel to talk a bit about how Looker and BigQuery ML are working together.
Thank you, Alex. So for starters, of course, you can use Looker to show the results that you've created with your BigQuery machine learning algorithms, but we can do a lot more than that with Looker. For those who aren't familiar, just a quick overview of how Looker works. Effectively, you can think of Looker as a business intelligence and data platform for your organization. Under the hood, mostly what it does is it takes questions that are asked for reports, converts that into SQL, pushes that down to the database and returns a result set for your end users. This works especially well with BigQuery because of the massive amounts of volume of data that BigQuery can handle and process in just a few seconds. Taking a step back here for a moment for what this machine learning data science workflow looked like without Looker, we'll just go through a few steps here and kind of talk about and add a little bit more to what Alex said in terms of what this looks like out in the wild, right? What we typically see is 3 components. First, data acquisition and transformation, then the machine learning component, and finally, actually productionalizing these machine learning projects. So starting at the beginning, what we'll see is there's a lot of steps involved in a traditional data science project. Gathering the data, having it all in one table, bringing that over to your machine learning software, and all the while doing transformations. And there's so many permutations of this. Either the transformations can happen at the source in some kind of database, or while they're in process in flight in the ETL, or finally actually doing that data munging, so to speak, in a tool like Python or R. Those tools that you're using it on your laptop, they're not really meant for that type of data transformation. And this whole process requires that the data scientists be familiar with many tools and deal with switching between them in different parts of this data science project. So it's really cumbersome. We're not really having a huge value add. This is not really what the data scientist was hired for. They're just making sure that they can get the data even ready to do the interesting stuff. So that, which ends up taking 70–80% of the time of a data scientist, is really what we end up doing instead of step 2, which is the machine learning component. So typical tools that data scientists are using, Python or R, this is really the interesting part, the meat of it, where we're going in and training these algorithms, doing feature selection, getting the results that we're interested in, iterating upon those. And note that sometimes data scientists have to go back to step 1 if things didn't work out the way that they wanted to in step 2, which again just lengthens the whole process, leading to those weeks or month-long data science projects that Alex was alluding to earlier. And then finally, we have the operationalization of these models, which oftentimes just doesn't even happen when the results are not necessarily as enticing enough to bring in the resources needed to operationalize this. This just becomes a science project. Occasionally, the data scientists are consulted to understand what the model actually was telling the business, but really it's not used in the day-to-day operations. If it is, that requires a whole other project where we're creating custom Python or HTML, JavaScript applications to get this information into the hands of the people that need it to do their jobs. So now that we have that as background, let's see how Looker and BigQuery really turns this entire process on its head. So starting kind of at the bottom here, we have BigQuery as the entire storage and transformation layer for all of the data. All of that processing happens in one place. We never need to move the data. We never need to do the ETL in flight. And we never need to switch between different processing tools. So if we have billions of records of data, we can just leave that in BigQuery and process it right there. We never have the data on our laptops where we're limited to maybe just a couple million records. Then Looker sitting on top of that is the logical layer. This is where we can define what all of those features are, all the metrics, in a really simple interface where we're using all the power of things like Python or R for version control, encapsulation, extensibility. All of those components, typically only used in programming languages, not in SQL, are now available for us in SQL itself. So we can create individual feature definitions inside of Looker, and Looker will handle assembling all of that into a larger SQL query to push down into BigQuery. So now we have one interface that we can work through, one place to process the data in BigQuery, one place to work in for doing the logic inside of Looker. And then we can push that forward into how do we actually operationalize this? How do we get this into the hands of the users that actually need this to do their jobs? Looker has lots of tools, of course, the front-end visualizations for just seeing the results themselves, but also pushing into other applications via webhooks or other tools that we can use to email or send this information to the users that actually need them, or even into automated processes like killing ad campaigns if they're not performing well enough and things like that. So that entire workflow can be done inside of Looker without having to create custom applications and leveraging the enormous power of BigQuery. So let's take a look at what this would actually look like in action. We're going to create this predictive model inside of Looker. So to start us off, we're just going to look at what creating one of these features or one of these fields inside of Looker would actually look like. We're going to jump off of that initial model that Alex had for us and make it a little bit more complex. And now you can see a little bit of how this works inside of Looker. So right here, I'm creating this will purchase in future some number of days, which in this case is a correlated subselect, but I can define it on its own with a parameter inside of Looker. So I don't need to worry about how this fits into the larger query. I have it encapsulated on its own. I've turned it into a binary classification that an end user in principle could parameterize to make this window that we're predicting into the future whatever size they want. Once I have this, now I can define a whole query that would actually use all of this. Again, using Looker's syntax. So here I have my training input. I have several columns that I'm using, not just the simple bounce rate and the session information, but a little bit more. Again, each one of these could be just as complex as that will purchase in future that I showed you just a moment ago. We can make these as simple as we want, like getting is mobile on the device, or something that might take into account much of the information about the session length and how they were navigating that website. Again, all of this is just fed in as a feature. I can add columns to this or remove columns from this. Very straightforward in setting this up. Once I'm ready, we can go down and actually start using BigQuery right here from Looker. So here I have this create or replace model, exactly the same syntax that we were looking at before. It's just now encapsulated in a small component. You'll see that the select statement is very small. We still have, of course, all the options, logistic regression, the label that we're using, maybe a few other ones as this model has progressed, and that lives in just this one location. Much easier to interact with, much easier to maintain the code. Of course, all of this is integrated with Git. Once we have this, of course, all of those other functions that are available to us, evaluating it, the ROC curve, the training information, all of that exists here. We can model that as well in Looker. And this culminates to a dashboard that we would be using that might look something like this. Here we have all of our accuracy metrics, recall, precision, etc., seeing and visualizing those curves, as well as the training details. How many iterations did it take? What does that loss look like over time, etc. And this is an interactive dashboard. While on the one hand we have these static metrics for the accuracy, recall, and precision, we can tune where we are on that precision recall curve to maybe make the most use of this model. So at the top I have this filter here. I'm just going to set my threshold to something new, rerun this, and most of the dashboard will stay the same, but you can see that the accuracy, recall, and precision change. Potentially if we're optimizing more for one than the other, we can use this method to play around with it. Once we're at a position where we're satisfied with this model, we can actually now start using it to predict unlabeled data, which of course is how this would be used at the end of the day. We'll just use BQML's predict function right here, inputting that model as well as some unlabeled data, and we can reference what that propensity score is right here at the bottom. Again, we can just define it once in Looker. We never have to worry again about how we access that. That's just there now for all of us to use. We can join this onto the rest of our data and actually see what this would look like for an end user who doesn't understand any of the machine learning components. They don't know what was used or involved in making this or how the data is even related to each other. And they can now use this in a use case here where they're going to use this to create a mailing list of users that are likely to purchase. So here we have some metrics that they might be interested in, the cost of those campaigns, the additional revenue, ultimately ending in that campaign ROI. And we're calculating this based on a few assumptions. You know, what is the cost per that campaign? What is the lifetime revenue of a customer, etc. Note that these themselves could be machine learning inputs to calculating all of these. In this example, we're just simplifying it down so that it's something that we can work with and that end user can just tweak those assumptions as needed. Now, as that data scientist might have informed us, we might want to change exactly what that threshold is. And now that I've set in a higher threshold, we can rerun this dashboard and it'll update those calculations, hopefully ending in a higher ROI. Once we have this as well, we can now use this and send this information to whatever our favorite emailing tool is. So something like Marketo to send those campaigns out. And we can just do that with this list that we have right here. We don't need to worry about copying it and pasting it and sending it and keeping track of that. All of this can be taken care of with simple webhooks that Looker has already enabled through our Action Hub. Once that's ready to go, we've kind of completed the entire loop. So we've gone from the beginning of getting that data prepared and ready, using Looker for the logic, BigQuery for the heavy lifting on the computational side and the machine learning training, all the way through to how we get this into the hands of the end users who don't need to know anything about the complexities of that machine learning algorithm. So I hope you've learned a little bit about how Looker works here. And back to you, Alex.
Thanks, Marcel. That was a really cool integration of Looker with BigQuery ML. So just as Marcel showed you, there's so many possibilities that you could expand on with BigQuery ML. Think about the different spaces in which bringing the power of machine learning to your data warehouse could really be an asset. So thinking about marketing, thinking about predicting funnel conversion, like the Google Analytics example, visitors to your site, predicting those which are going to you should be targeting and which you can target for converting into purchases and sales. retail, thinking about the example of optimizing inventory. We've seen this example of businesses using the data on their inventory and predicting where they need to be purchasing in order to anticipate demand. We've seen some really interesting industrial and IoT applications. So with Geotab, that was an example where they've been doing forecasting for parking, traffic, and weather, or using weather data, but also things like tracking maintenance needs, using IoT devices who are measuring levels of materials in industrial and factory contexts, and predicting where things are going to need to be maintained, where supplies are going to need to be ordered. And media and gaming, like 20th Century Fox example of doing audience propensity score generation and personalizing content for gaming. So there's so many possibilities available now that we're empowering data analysts with this machine learning tool in BigQuery ML. So what's next? What do? You identify forecasting and classification problems in your own organization. You have so much data sitting here in your data warehouse. How can you start thinking about ways of doing forecasting and classification? Where can you do that transformation? How can you empower data analysts to do that? You can learn more about how to use BigQuery and BigQuery ML in our Google Cloud Platform's Data to Insights course on Google Cloud Platform. So check out our course on Coursera. You can try out Google Cloud's tools and BigQuery ML at cloud.google.com/BigQuery. And you can also check out BigQuery ML on looker.com. If you have any feedback, BigQuery ML is in beta. Always excited to look for more feedback. Send an email to the BigQuery team, bqml-feedback@google.com, and they will definitely check that out. Well, thanks for joining us today. Please stay tuned for the next session. We hope you enjoy the conference.